Alright, so in this video, I wanted to go over how to add, subtract, multiply, and divide exponents. We have to have this and have a good foundation of how to do this before we get into exponential functions. So you should have your foldable out that I gave you Friday, and in the first part of these videos that I'm uploading today, it explains how to set up your foldable. So looking on the back side, you should be putting down at this big bro, little bro. When I say big bro, little bro, talking about exponents, I mean big bro is going to be our base to our exponent. So whatever is being raised to the exponent is going to be our big bro. Then our little bro is going to be our thing that our base was raised to. So it could be a variable, it could be a number. Our big bro could also be a letter or a number. So big bro is always 2 years ahead of little bro. When we learn our operations, we learn it in the order addition, subtraction, multiplication, and division. So the reason why I use big bro, little bro is we're going to go in the order addition, subtraction, multiplication, and division. So looking at the first example, we've got addition. So big bro, I'm going to put big. Big bro is learning addition in his first year of school. Little bro, though, is 2 years behind, so he's not even in school. So our big bros are our x's. They're old enough to know how to do addition, so we have our understood ones. So we're going to be able to add the big bros together. Due to the fact that our little bros, which are our exponents, our threes, are not even in school and have learned addition, they simply stay the exact same. They're kind of just there. So now we move on to subtraction. Well, now big bro is learning how to subtract. Well, if big bro is learning how to subtract 2 years behind, little bro is still not learning how to add. So big bro is going to be able to subtract. So we've got 1 and 1 here. And actually we're going to make this 2. So change this on your sheet of paper, 2. So we've got 2 minus 2, which gives us 1x. So big bros are being able to subtract. Now, little bro still hasn't gotten to school yet, so our exponents 5s are just kind of there. So they're not subtracting or adding or anything like that. They're just staying the exact same. Now, what if big bro has finally gone through and learned how to multiply? Well, 2 years behind big bro is little bro, so little bro is finally at adding. So looking at when big bro is multiplying, so we've got 1 times 1, which is just 1x. We've got our little bros, our exponents 2 and 4 are adding. So we've got 2 plus 4. So all of that together, we have 1x raised to the 6th power. Now if big bro is learning how to divide, little bro is 2 years behind him. So our bases, or our big bros, have 1x divided by 1x. And if you need to rewrite this, it's fine. It's 1x to the 6th power divided by 1x to the 2nd power. So 1x divided by 1x is simply 1x. And then little bro is learning finally how to subtract. So we've got our 6 and our 2. We're going to do it in order. So 6 minus 2. So 6 minus 2 is going to give us 1x to the 4th power. So if the little bro and big bro does not help you, then just know addition and subtraction in between exponents, you're keeping the exponents exactly the same and just adding or subtracting at the bases. If you're multiplying and dividing, you're either adding when you're multiplying the bases and subtracting it when you're dividing. So now you're going to flip your foldable over and go to your first foldable, or your first flap. Product of powers properties. So when you have a product of powers property, your steps are multiplying the coefficients, keeping the bases, and adding the exponents. So in this one, we are seeing that there is multiplication, so that's that product word, and you are multiplying the bases, which in this case are a's, and you're getting this a in your answer. This all should be on the first little flap. You're going to turn it over, and right under all of these steps, you're still writing this example right under those steps. We're going to go over an actual step in a second to go on the right side. Once you multiply the coefficients, then you're keeping the bases the same, which you're good. Already did that. Then you're going to add the exponents. So you've got m plus n, which gives you your m plus n. So, example. So first thing we want to do is multiply our coefficients. So we've got 3 times 3. So we're going to do that. Then we're also going to add our exponents. So once we do this, we have 3 times 3, which is 9. And at the top, we've got 2 plus 3, which is 5. So we end up with 9 to the 5th power. And remember, if you wanted to solve this, right now we're just simplifying it, understanding the exponent properties. But if you want to simplify all the way, this means 9 times 9 times 9 times 9 times 9. Because there is 1, 2, 3, 4, 5 9s multiplied together. Now, on to the next one. Remember, this is under the example in the middle of the foldable. Now the next flap, power of power property. So this is when you're raising a power to a power. So you're going to raise the coefficient, keep the base, and multiply each exponent inside of the parentheses by the outside exponent. So you're going to multiply. You've got multiplication in between that m and that n. You're also, if there is a coefficient other than 1, you are also raising that coefficient to that exponent. And you're going to keep the base like we have these x's. So let's look at an actual example. So we have 6 to the 4th power raised to the 4th. So you're going to raise the fourth, so you're going to multiply these. So you're going to have 6 to the 16th power. So if you wanted to expand this so you could simplify, you would have 6 times 6 times 6 times 6, all the way until you had 16 6, which would take forever. Another example of this would be if you had 6x raised to the fourth, all raised to the fourth power. So this is what I was talking about right now. This 6 has an exponent of 1, and then the x is raised to that fourth inside of the parentheses. So if you had a coefficient, you would have to raise it to that outside power. So this would give you 6 raised to the fourth power times x to the 16th power. So the next one is the quotient of powers property. This is when you're dividing the powers with like bases. Keyword like bases. So you gotta have like bases when you're doing this. So divide at the coefficients. So the coefficients of the example is 1 divided by 1, which is simply 1. Keep the bases, which is the a's. Then subtract the exponents in the denominator from the exponents in the numerator. So subtract the exponents from the numerator. So you're starting with the top, the numerator's exponent, then subtracting the bottom from it. So numerator first, denominator second. So example of this. Key thing to remember, do we have like bases? We have our 3's as our like bases, so we're good. So we have 3 that stays the same, then we have our numerator exponent first, then our denominator exponent second. So this simplifies as 3 to the second power, which is the same thing as saying 3 times 3, which is 9. So power of a product or quotient property. So this is when a product or quotient with like bases is raised to a power. So you're going to have multiplication or division in parentheses, and then it's going to be raised to an exponent. So how we solve this is raise all coefficients. So you're going to raise all coefficients to that exponent outside of the parentheses, keep bases, and raise every inside of the parentheses up by the outside exponent. So whatever is in the parentheses is going to get raised to that exponent. So right now the a has a 1 exponent, and the b is raised to the 1. So that is why we're ending up with that understood 1a raised to the m, and that b raised to the m as well. So here's an actual example. So right now we have 2 raised to an understood 1 times 4 raised to an understood 1. We're going to distribute. So we have 2 raised to the 4th times 4 raised to the 4th. Then we can go back to one of our other properties that we've already learned, and we've got multiplication. So our basis is our big brother, remember, and he has already learned multiplication, so he can do 2 times 4, which is 8. And if big bro is doing multiplication, little bro or our exponents are adding. So we've got 4 plus 4. So we end up with 8 to the 8th power. Now for the second one, you can rewrite it as 2 over 4 raised to the second. Right now, our 2 is raised to the first power. Our 4 is raised to the first power. We are distributing that 2 out. So we have 2 raised to the second power, 4 raised to the second power. Now we can simply go ahead and solve this, or we can go through the steps of simplifying our exponents and then deal with our 2 and our 4. So we can do 2 squared, which is 4, 4 squared, which is 16, and then go through it from there. So we would have 1 over 4. Now, negative power property, I think, is one of the harder ones. When you have a value raised to a negative exponent, move it to the opposite side of the fraction bar to make it the exponential or the exponent positive. So as soon as you, because remember there's a understood 1 underneath anything that doesn't have a fraction bar. Once you move this base and this exponent that's negative into the denominator and flip it, the n becomes positive. So let's look at an example. We have a 5 raised to the negative 1. We already have an understood 1 underneath. So once we flip it, we have 1 over 5 raised to the 1, and it's positive. Now for this example, the second example, we've got division. We've got 2x divided by 2x, which is just 1x. Then we are subtracting because big brothers are dividing, so little brothers, the exponents, are subtracting. So we have negative 2 minus 4, which is going to give us x raised to the negative 6th power. Right now we have understood divide by 1. We're going to flip it to make the exponent positive. So we have 1 over x raised to the 6th power, and that would be our answer. And then lastly, we have 0 power property. Any non-zero value raised to the 0 power equals 1. So as long as you see this 0 in the exponent, I don't care what, if there's an x, if there's 100x, whatever it is, it's going to equal 1. So if we had 8 raised to the 0 power, again, as long as we have that 0 in the exponent, it is 1. Now, long way to look at the second example is you're going to have to distribute that 0 in. So you're going to have 6 raised to the 4 times 0. Well, what is 4 times 0? 0. So as 6 is raised to the 0 power, it's simply going to be 1. And that is all. So during this virtual day, you need to have all of these copied down, and I'm going to be checking them Tuesday.